Deep beneath the surface of our planet, something is shifting. It is slow, it is silent, but it is not normal. Instruments buried in rock and soil are picking up signals that were not there before. Tiny earthquakes, subtle ground movement, changes in gas that should not be happening this way. To most people, this goes completely unnoticed. But to scientists, it is a warning. For years, this volcano stayed quiet, too quiet. History shows that when volcanoes sleep for a long time, pressure builds deep underground. Magma rises, gases get trapped, the earth stretches and cracks under stress. Right now, all of those signs are appearing in one place. And there is one detail that keeps showing up again and again in scientific reports. This is not speculation from social media. This is not a rumor. This comes from seismic data, satellite measurements, and long-term geological models. Independent research teams are watching the same signals and reaching similar conclusions. Something is moving toward a critical point, and once that point is crossed, there is no way to stop what comes next. In this video, you will learn which volcano scientists are watching most closely. You will learn why this specific volcano is far more dangerous than most people realize. You will discover what has already changed beneath the ground and why experts say the current activity looks disturbingly familiar. These patterns have been seen before. The last time they appeared, the outcome was devastating. You will also learn why the year 2026 matters so much. Not as a prediction pulled from thin air, but as a window based on pressure cycles, magma movement, and historical timelines. You will see how decades of quiet activity can be more dangerous than frequent small eruptions. And you will understand why this volcano does not need to erupt directly near cities to cause global damage. Most people think volcanic disasters are local events. Lava destroys nearby towns, ash falls in surrounding areas. Then life goes on. That belief is dangerously outdated. Modern science shows that large eruptions can affect the entire planet. Air travel can shut down across continents. Temperatures can drop worldwide. Food production can suffer. Economies can take years to recover. And all of this can start from one single event deep inside the Earth. There are also details most news reports never mention. Lesser-known warning signs that are easy to overlook. Strange patterns in underground earthquakes, chemical changes that only appear before major eruptions, satellite data showing ground swelling by just a few centimeters, which may not sound like much, but signals massive pressure below. These are the clues experts are quietly debating right now. As this video unfolds, you will see why scientists are uneasy. Not panicked, but concerned. Monitoring systems are active. Data is coming in daily. Yet there is a growing realization that even the best technology may not give enough warning time. Some eruptions escalate in weeks, others in days. A few happen with almost no notice at all. You'll also learn why this volcano is different from others. Its structure, its eruption history, the type of magma trapped below. These factors decide whether an eruption is slow and predictable or sudden and explosive. And this volcano has a history that makes experts pay attention when activity starts to rise. By the end of this video, you will understand why researchers are using words like critical, unstable, and overdue. You will know what could realistically happen if the pressure continues to build. And you will see why the next few years are being treated as a crucial period in volcanic science. This is not about fear. It is about awareness. The Earth has followed these cycles long before humans existed. The difference now is that billions of lives depend on what happens next. Understanding the warning signs matters. Knowing the risks matters. And paying attention before an event happens is far more important than reacting after it is too late. Watch this video until the end, because every section builds on the last. Each detail connects to a bigger picture that most people never see. By the final moments, you will understand why scientists are not asking if this volcano will change, but when.
Welcome to our channel, where we break down hidden threats, real science, and the forces shaping our planet. If you want more videos like this, subscribe now and stay with us as we uncover what the Earth is preparing to do next.
Volcanoes erupt all over the world every year. Most of them follow a familiar pattern. Pressure builds, lava slowly rises, and small eruptions release energy before it becomes overwhelming. These events are dramatic, but they are often predictable. Scientists can usually spot the signs early and issue warnings in time. This is how people tend to think all volcanoes work. But this volcano does not follow those rules. Instead of releasing pressure regularly, it stays quiet for long stretches of time. Years pass, sometimes centuries. On the surface, everything looks stable. There is no lava flow, no ash clouds, no constant activity to draw attention. But deep underground, pressure continues to grow. Magma thickens. Gas becomes trapped. The system seals itself, turning the volcano into a massive natural pressure chamber. When this type of volcano finally erupts, it does not do so gently. Its past eruptions were not frequent, but they were extreme. Explosive bursts sent ash high into the atmosphere. Shockwaves traveled far beyond the eruption site. Entire landscapes were reshaped in a matter of hours. These were not events that affected only nearby areas. Their impact spread far wider and lasted much longer. Another unusual feature is how slowly the warning signs appear. Instead of obvious changes, the signals are subtle. Small ground movements, deep earthquakes that do not break the surface, gas emissions that change in composition rather than volume. These clues are easy to miss unless you know exactly what to look for. This makes the volcano harder to read and easier to underestimate. Long periods of silence are what make it especially dangerous. Each quiet year allows more pressure to build. The longer it stays dormant, the more energy it stores. By the time activity becomes obvious, the system may already be near its limit. At that stage, the margin for error becomes very small, and the behavior of the volcano becomes much harder to control or predict. Right now, the ground around the volcano is slowly changing shape. It is not dramatic enough to notice with the naked eye, but satellites can see it clearly. Large sections of land are lifting by small amounts, sometimes only a few centimeters. This swelling means magma is pushing upward from deep below. Rock is being forced apart, creating space for molten material to move and collect. This kind of deformation does not happen without a cause, and it rarely reverses on its own. At the same time, earthquake activity is increasing beneath the surface. These are not the sharp, destructive earthquakes people usually think about. They are smaller and deeper. Many of them occur in clusters, forming patterns that suggest magma is breaking through solid rock. Each tremor marks a crack forming or expanding underground. When these events begin to line up in depth and location, scientists take notice because it often signals that magma is finding a pathway upward. Gas readings are also changing in ways that raise concern. Instruments near the volcano are detecting shifts in gases like sulfur dioxide and carbon dioxide. The amounts are not always higher, but their ratios are different. This suggests fresh magma is moving closer to the surface. As magma rises, it releases gases that were previously trapped under extreme pressure. These chemical changes can act as an early signal that the system is becoming more active even before an eruption appears possible. Heat patterns underground are shifting as well. Thermal sensors show warmer zones spreading beneath the volcano. Areas that were once stable are now heating unevenly, which points to magma movement rather than normal geothermal activity. This heat does not move in straight lines. It follows fractures and weak points in the rock, slowly reshaping the internal structure of the volcano. Together, these signals form a picture of a system that is no longer resting, but quietly reorganizing itself from the inside. The year 2026 did not appear suddenly in scientific discussions. It is the result of pressure building deep underground over a very long time. This volcano does not release energy often, so stress accumulates slowly but steadily. Decades of trapped magma and gas have pushed against solid rock with nowhere to escape. Each year of silence adds to that strain, tightening the system like a sealed container under heat. What makes the current moment stand out is how closely today's activity matches patterns seen before earlier major eruptions. Ground deformation, deep earthquake clusters, and gas chemistry changes are lining up in a familiar sequence. These signals appeared months or years before past explosive events following a similar order and pace. Scientists compare present data with historical records, and the overlap is difficult to ignore. The volcano appears to be moving through stages rather than showing random behavior. Computer models help connect these observations. They combine seismic data, satellite measurements, gas output, and rock mechanics to simulate how pressure moves underground. When these models are run using current conditions, many of them point toward a narrow window when the internal system becomes unstable. That window is not exact to a single day, but it clusters strongly around the mid-2020s. 2026 sits near the center of that range. This timing is also supported by the rate of change scientists are measuring now. The ground is swelling faster than it did in previous decades. Earthquakes are occurring at depths that suggest magma is no longer stationary. Heat is spreading into new zones beneath the volcano. These changes are happening gradually but consistently, which allows researchers to estimate how long the system can continue before reaching a breaking point. That is why 2026 keeps appearing in reports and discussions. It is not based on intuition or fear.
It comes from long-term data, repeated patterns, and calculated projections that suggest the volcano is moving closer to a critical threshold rather than drifting away from it. If this volcano erupts, the first sign may not be lava. It could be a towering ash cloud rising rapidly into the sky. Fine particles of rock and glass would be blasted upward with enormous force, spreading far beyond the immediate area. These particles are light enough to stay suspended in the atmosphere for long periods, carried by high-altitude winds across regions and even continents. Visibility would drop, air quality would decline, and the sky could darken hundreds of kilometers away from the eruption site. One of the fastest global impacts would be on air travel. Volcanic ash is extremely dangerous for jet engines. Even small amounts can cause engine failure. As ash spreads through flight corridors, large sections of airspace would need to be closed. This has happened before on a much smaller scale, grounding thousands of flights for days. An eruption of this magnitude could disrupt international travel for weeks, affecting supply chains, emergency services, and economies that rely on constant movement of goods and people. Beyond the immediate chaos, the atmosphere itself could begin to change. Volcanic ash and sulfur gases can reflect sunlight back into space. When enough material reaches the upper atmosphere, it can lead to temporary cooling at the surface. Temperatures may drop slightly, but across wide areas. Growing seasons can shorten. Weather patterns can shift. These effects are not uniform, making them difficult to predict and manage. The damage would not stop near the volcano. Ash falling on farmland can ruin crops. Water sources can become contaminated. Infrastructure can weaken under the weight of fine debris. Electrical systems can fail as particles infiltrate equipment. Even regions far from the eruption could feel the impact through rising food prices, transportation delays, and economic strain. A single eruption can ripple outward, turning a geological event into a global disruption that reaches places with no direct connection to the volcano itself. In a worst-case scenario, the eruption would not build slowly or offer clear warning signs at the surface. Pressure that has been trapped for decades could be released in a sudden and violent explosion. Thick magma and compressed gas would burst upward at once, breaking through rock that has been holding it down. The force of this release could send ash and debris high into the atmosphere within hours, leaving little time for preparation beyond what monitoring systems already provide. As ash and gas spread into the upper layers of the atmosphere, the effects could last far longer than the eruption itself. Fine particles can remain suspended for months or even years. During that time, sunlight reaching the surface would be reduced. Temperatures could drop across large regions. This is often described as a volcanic winter, not because the world freezes, but because the climate becomes cooler, darker, and less stable. Weather patterns may shift in ways that disrupt rainfall and growing seasons. Food production would be one of the most vulnerable systems. Crops depend on predictable sunlight and temperature. Shorter growing seasons and unexpected frosts can reduce yields. Ash settling on farmland can damage soil and block plant growth. In some regions, livestock could be affected by contaminated water and feed. These problems would not be limited to one country. Modern food systems are global, and shortages in one area can quickly affect markets everywhere. Economic stress would follow closely behind. Transportation disruptions, crop losses, and energy supply issues would place pressure on national economies. Prices for basic goods could rise as supply chains struggle to adapt. Industries dependent on travel, agriculture, and manufacturing would feel the strain almost immediately. Financial markets could react to uncertainty, spreading the impact across borders. Even countries far from the eruption could experience lasting effects as the interconnected nature of the global economy turns a single natural event into a widespread economic challenge. Around the volcano, monitoring systems are already in place. Seismometers track underground movement day and night. Satellites measure changes in the ground from space. Sensors analyze gas escaping from cracks and vents. Together, these tools give scientists a detailed view of what is happening below the surface. Compared to the past, this level of observation is advanced, and it continues to improve as new technology is added. Despite this, monitoring does not always equal certainty. Some volcanic systems change slowly, while others shift rapidly. In certain cases, the most dangerous phase begins only days or hours before an eruption. Warning signs can escalate faster than Friends plans can keep up. Data may show that pressure is rising, but it cannot always predict the exact moment when rock will fail and magma will break through. Evacuation presents another challenge. Large populations live near active volcanic zones, often because fertile soil and access to resources make these areas attractive. Moving tens of hundreds of thousands of people on short notice is extremely difficult. Roads can become congested. Communication can break down. Some communities may hesitate to leave if they have experienced false alarms in the past. These delays can increase risk when time is limited. On a global scale, readiness becomes even more uncertain. While local authorities may have plans in place, the wider impacts of a major eruption extend far beyond national borders. Airspace closures, trade disruptions, and climate effects require international coordination. Not all countries have the same level of preparation or resources. Emergency systems are often designed for regional disasters, not events that affect multiple continents at once. This raises serious questions about how well the world could respond if the situation escalates quickly and the consequences spread faster than expected. One of the biggest concerns among experts is how quickly the situation could change. Volcanic systems do not always follow a slow, steady buildup. In some cases, months of minor activity are followed by a rapid escalation that unfolds in a matter of days. Pressure can reach a tipping point suddenly, leaving very little time for decisions. Even with constant monitoring, the speed of these changes can outpace emergency planning and public response. Another major worry is the eruption style itself. Not all eruptions behave the same way, even within the same volcano. Past events show that this system is capable of shifting between different eruption modes. It could begin with ash release and then turn explosive without warning. It could also bypass smaller stages entirely and erupt violently from the start. This unpredictability makes it harder to prepare specific response plans, since the initial behavior often determines how dangerous the event becomes. There is also concern about how an eruption could interact with other natural systems. Large amounts of ash and gas can influence weather patterns, ocean temperatures, and even nearby fault lines. Heavy ashfall can trigger landslides or lahars, especially if rain follows an eruption. Changes in atmospheric circulation can affect storms far from the source. These chain reactions add layers of complexity that go beyond the volcano itself, turning one event into a series of connected impacts. Perhaps the most troubling issue is human perception of risk. Long periods of quiet can create a false sense of security. Communities adapt to living near danger and begin to see it as normal. Decision makers may delay action to avoid economic disruption or public panic. History shows that underestimating volcanic risk is common, especially when the threat does not appear immediate. This gap between scientific concern and public response is something experts watch closely, knowing that awareness often lags behind reality. Understood. I'm ready to continue. Send me the next section title, or tell me when you want me to write the final conclusion, and I'll keep the same tone, flow, and structure without summaries until the end. So now the focus remains on constant observation. Scientists are keeping a close watch on the volcano through continuous monitoring systems that operate around the clock. Seismic stations record even the smallest movements underground. Satellites pass overhead regularly, measuring changes in the shape of the land. Gas sensors and thermal instruments add more layers of data. This steady stream of information is expected to continue all the way through 2026, with no plans to scale back. Each month brings new data that slightly reshapes the understanding of what is happening below the surface. Some changes are subtle, barely noticeable from one report to the next. Others stand out immediately, forcing experts to revise their assessments. Patterns are compared over time rather than in isolation. A single quiet month does not erase years of buildup, and a sudden spike can shift concern levels quickly. This constant reevaluation is part of the process, even when answers remain uncertain. One of the key challenges is that risk does not always increase gradually. Volcanic systems can remain relatively stable for long periods and then change rapidly. Earthquake frequency can jump. Gas output can shift direction. Ground swelling can accelerate. When these changes happen together, risk levels may rise suddenly, leaving little room for hesitation. This is why scientists avoid fixed predictions and instead focus on trends that can change without warning. As monitoring continues, the situation remains open and unfinished. There is no single moment when the outcome becomes clear. New information can confirm earlier concerns or raise entirely new questions. The volcano is still active beneath the surface, adjusting and responding to forces that cannot be seen directly. Until those processes settle or release their pressure, the story remains in motion, shaped by data that continues to arrive and signals that are still being interpreted. The Earth has followed these cycles long before modern cities, satellites, or warning systems existed. Layers of rock hold the record of past events, showing that powerful eruptions are not rare in geological time. They happen when pressure reaches its limit and the planet adjusts itself. These events are not acts of intention or warning. They are natural responses to forces that build slowly and release suddenly. Despite advances in science and technology, humans have never fully controlled these processes. Monitoring tools can observe, measure, and estimate, but they cannot stop magma from rising or pressure from breaking rock. Even the most advanced models rely on patterns from the past, not certainty about the future. This gap between knowledge and control remains, no matter how sophisticated the tools become. As the calendar moves forward, 2026 is drawing closer. Each passing year adds context to the data being collected now. Ground movement, earthquakes, heat, and gas changes are not isolated events. They are part of a larger system that continues to evolve. Time does not reset the pressure building below. It only changes how close that system is to a critical point. The volcano itself is no longer quiet in the way it once was. Its signals may be subtle, but they are persistent. Small movements replace long silence. Chemical changes replace stability. These signs suggest ongoing activity rather than rest. The surface may look calm, but beneath it, the system remains active and unsettled. The story is still being written underground, and the forces at work are continuing to shape what comes next. All the signs point to a planet that is active, complex, and never truly still. The data being collected today is not random noise. It is part of a pattern that scientists recognize, even if the final outcome cannot be timed to a single moment. Pressure continues to build, signals continue to shift, and the systems beneath the surface continue to move in ways that demand attention. This is not about predicting disaster for the sake of fear. It is about understanding how the Earth works and recognizing that powerful natural forces operate on timelines much larger than human planning. History shows that when these forces reach their limits, the effects can spread far beyond one location. Awareness, preparation, and respect for these processes matter more than certainty. As 2026 approaches, the importance of watching closely becomes even greater. Every new piece of data adds to the picture. Every small change carries meaning. The volcano is not silent, and the planet is not finished shaping what comes next. If you found this video informative, take a moment to like it. It helps support the channel and reach more people. Subscribe to our channel for more deep dives into real science, hidden risks, and the forces shaping our world. Stay curious, stay informed, and stay with us for what comes next.